So we're continuing on the trend with radicals. And we're going to be simplifying radical expressions that involve addition and subtraction. Here is the key. We are combining like terms. If you have a square root and a cube root, they are not like terms. It's like having an x and a y. So really, when you're thinking about this, think about combining like terms and having the root has to be the same so you can combine them. So I have 3 square root of 5, 7 square root of 5. They are like terms. Square root of 5 is the same as square root of 5. I can go ahead and add those together to get 10 square root of 5. In B, the first 2 terms are obviously like terms, right? Square root of 11, square root of 11. The square root of 44, however, can be written as 4 times 11. I can take the square root of 4, which is 2, times 3, which is 6. Now I have like terms. 2 minus 1 is 1, plus 6 is 7. So the caveat to finding like terms here is you might be able to make something be a like term. So always look at that. Here I have 12 and 75. Is there anything I can do to these to force them to be like terms? Well, 12 is divisible by 4. And 75 is divisible by 25. Let's see where that gets us. The square root of 4 is 2. The square root of 25 is 5. And look at what happens to these now. They are now like terms. I can then combine them. The square root of 5 and the square root of 10. I can't do anything to 10. I can make it 2 times 5, but I can't take the square root of 2. So there's nothing I can do to make these alike. The key when you're making them alike is that you've got a perfect square and you can take that perfect square out. Like here, 25, the square root of it is 5. 6 times 5 is 30. 2 times 5, I can't do anything with that. Now if I'm subtracting, the same rules apply, but I've got to see if I can get like terms. So I'm going to say, okay, is 162 divisible by a perfect 4th power? Well, what's 2 to the 4th? What's 3 to the 4th? 3 to the 4th is 81. It's divisible by that. 2 to the 4th is 16. 32 is divisible by that. There is no quicker way, even with the calculator, other than you just thinking about, okay, what is 2 to the 4th? Okay, that's 16. Is 32 divisible by 16? What is 3 to the 4th? Well, that's 81. Is this divisible by 81? And usually, if you check by 2, 3, 4, and 5, if it doesn't get divided into one of those, you can stop. Well, the 4th root of 16 is 2. The 4th root of 81 is 3. I do the multiplication there. Then I combine my like terms. In part B, the same thing is going to occur. P to the 4th can be written as P cubed times P. P to the 7th can be written as Q to the 7th can be written as Q to the 6th times Q. Well, I can take the cube root of P to the 3rd and Q to the 6th because 3 divided by 3 is 1. 6 divided by 3 is 2. Now I have like terms. Now, because this is a variable minus a number, that's as far as I can really take it. And that's okay. You can leave it in that form. Now I have a cube root and a square root. What do we do here? Well, I'm going to do the same thing. I'm going to work on breaking things out. I know that 16 is divisible by 8, which is a perfect cube. I know that 200 is divisible by 100, which is a perfect square. Then I break out my variables. Z to the 6th is divisible by 3, so that's good. 4th is divisible by 2. Once I do that, I simplify those roots, and I get here. Now I have the cube root of 2z and the square root of 2z. These are not like terms. I cannot combine them. So I went through all of those steps, not to combine those last terms, but to simplify the actual radicals. Here, you've got to remember that the square root is going to distribute to the top and the bottom. My top is divisible by 16, which is a perfect square. Here, This is divisible by 9, which is a perfect square. And then I'm just distributing that root into the bottom. The square root of 36 is 6. The square root of 16 is 4. But I still have that square root of 2 hanging out. The square root of 9 is 3. But I still have this other 3 hanging out. And then I have 6 times the square root of 3. What do I do here? What happened between these steps? Well, 2 times 4 over 6 would be what? That would be 8 over 6, which reduces to 4/3. That's what you're doing here. 2 times 4 divided by 6 reduces to 4/3. 3 times 2 is 6 divided by 6, which is 1. And then I have square root of 3 divided by square root of 3, which is really 1. But why did I change it? I changed it to get a common denominator. So even though this would reduce down to 1, I need to combine it with this fraction over here. So I'm doing times 3 over 3 to get a common denominator, and then I'm combining them into one fraction. You may want to go back and watch this a second time because it's going to make sense. So pause, rewind, watch it a second time as I go through the steps, and it's going to make more sense than just watching it through one time. Then last, I have the square root of 80 over y to the 4th, square root of 81 over y to the 10th. I'm going to break that out into perfect squares. 80 is 16 times 5. I distribute the square root to the denominator as well. The square root of 81, distributing that square root again. 4 times the square root of 5. I did 4 divided by 2, which is my index, to get 2. 10 divided by 2, which is my index, to get 5. I want a common denominator. If I multiply the top and the bottom by y to the 3rd, 2 plus 3 is 5. I get a common denominator. So I can combine the top, and the y to the cubed is just written in front of the radical because that's how we prefer to write it. And I've added them across. Again, pause, rewind, watch this again at each step, verifying each thing that we're doing. Section 4 is putting everything together, including what you've known in your elementary algebra class.